I was just coming to New York. I was making plane Boston stuff.
All right, so I think we should get started. Not to cut you guys off. Okay, so we're gonna try to maybe like cover like some of like the pertinent aspects of the three lectures, and uh, just to put it out there, so I don't really know everything about each lecture. So I'm try to give you guys, maybe some of the stuff that I understood, like from the lectures, and if you guys feel like maybe, or if you want to contribute, feel free to contribute so that like everyone leaves with a more complete, understanding of, what we're looking at, right? Right? Okay, so what are the three lectures that we're talking about? So we have the ascending pathways, right? Right, this is Dr. Gondry Lewis. This is your lecture, right? Um, so ascending pathways. Then we have the orbit lecture. And this was by Dr. Gillen, right? And then we have the Thalamus lecture. And this was by Dr. Burke. All right, so we're going to start off here with the ascending pathways. All right. So I guess just kind of like looking at the name. So ascending pathways, meaning like you're going back, right? So you're going back to your brain. So if we're, let's say this is someone right here. All right, this is someone. So if we're saying ascending, then we're saying that the information is going back, right, to the brain, right? As opposed to the information actually like going from the brain to the rest of the body, right? So this is the body, and then this is the brain, right? We're saying that the information is moving from the body to the brain, right? Thereby it's ascending, right? So this would be like afferent, right? Right? If it was going like this, right, it would be efferent, right? So we're going to be looking at this kind of afferent information, the information that is ascending back up to the brain, right? So this information that is ascending to the brain is going to be sensory, right? This is going to be sensory information, right? So it turns out that this information that is sensory, when it moves back up to the brain, all right, so the brain, so even though it moves up to the brain, some of that information you can perceive and some of it you can't perceive, right? So this sensory information that travels up to your brain, some of it you can personally like perceive it, and then some of it you cannot perceive it. So there's an aspect of this information, or this an aspect of this sensory information is going to be conscious, all right? And then another aspect would be unconscious, right? Probably butchered this name. All right, so an aspect is going to be conscious, and another aspect is going to be unconscious. So the conscious information, right? The conscious sensory information, right? So the sensory information that's coming from your body to your brain, the aspect of it that's conscious is the one that you actually perceive. So that's the one that actually reaches your, like, it actually reaches, like, the cortex, right? So it actually reaches your cerebral cortex. Whereas the unconscious is more like the lower, like your lower brain, like it's like your brain stem, like cerebellum. So the one that goes up to your cerebral cortex, you'll be actually consciously aware of it. Whereas the one that like goes up to your brain stem or like your cerebellum, you're not going to be conscious of that information. It's going to be unconscious. Even though that information is going up to your brain, you're not going to be aware of it, right? So in terms of the conscious sensory information, so we're going to have two different tracks, right? So we're going to have the dorsal column, right, also known as your medial lemniscus, right? And then we're going to have the Spinothalamic Tract, also known as your anterolateral system. All right, so when we're looking at this sensory information that is going to be ascending, so this information is going to be sensory information that we're getting from the periphery, from the body, right? It's going to be traveling up to the brain, right? So we're saying that this information that's traveling up to the brain, we can either perceive it or we might not perceive it. The one that we can perceive, right, are going to be the ones for the dorsal column, right? And for the Spinothalamic Tract. Okay, so the dorsal columns, so the kind of sensory information that the dorsal column is going to be relaying back up to your brain is going to be fine touch, right? Proprioception, and pressure, right? Spinal Thalamic Tract is going to be relaying pain and temperature. Cool? So pain and temperature, right, from your body is going to be perceived by your brain through your Spinothalamic Tract. And then fine touch, proprioception, pressure, it's going to be going back to your brain through the dorsal column. This is also crude touch. Sorry, go ahead. Crude touch as well. Cool. And then for the unconscious, we're going to have the Spinocerebellar Tracts. All right, so at the end of the day, these two guys right here are going to go all the way up to your cerebral cortex. All right. Now, when we're looking at the spinocerebellar, this guy right here, so this guy's going back to, it's going up to the cerebellum. All right. I mean, sorry, the cerebellum. Yeah, the cerebellum. So because it's going up to the cerebellum and not like the cerebral cortex, like the higher centers of your brain, that's why you're not going to be consciously aware of that information. Does that make sense? So it was like in the lower areas of your brain. Right? So these are the three major tracks that Dr. Gondry Lewis talks about in her lecture, right? All right, so I'm trying to give you guys a way of kind of seeing it, right? So when we're talking about ascending pathways, we're simply talking about sensory information moving from your body, right? So we pick up sensory information, right? So it could be fine touch, pressure, proprioception, pain, right? Whatever from your body, right? Then that information is now going to travel through tracks, and then it's going to go up to your brain. All right? Depending on where that information stops, you might be able to consciously perceive it, or you might not be able to consciously perceive it. So if that information is stopping at the lower areas of your brain, you're not going to be consciously aware of it. But if it's at the higher areas, such as your cerebral cortex, then you will be consciously aware of it. So the three tracks, the three major tracks. So for the conscious one, we're talking about the dorsal columns, medial lemniscus is the same thing, right? Dorsal column, medial lemniscus, spinothalamic tract, same thing as your anterior lateral system, is the same thing. And then for the unconscious, we have the spinocerebellar tracts. And the spinocerebellar tract, we'll get into it later, but it's actually divided into it has two parts to it. So it has the I believe, I'll find it here. Anterior, posterior, let me just be sure. So you have the dorsal, right? And then you're going to have the ventral, right? So the ventral is also the anterior, So you're going to have a dorsal aspect to it, or dorsal pathway, and a ventral pathway, right? And so it turns out that the dorsal pathway is actually like further divided up. Like it's even broken down further, right? So it's broken down further to your cuneo-cerebellar tract. And this is a little bit confusing why they call it this, but also your dorsal spinal cerebellar tract. Cool? So are you guys good with this so far? Yeah. All right. So there's three major tracts. So we have the dorsal column, Spinothalamic tract, and the spinocerebellar tracts. So for the spinocerebellar tracts, the kind of information that it's going to be relaying to the cerebellum, so it's going to be proprioception, right? And Dr. Gondry Lewis had kinesthesia. I was a little bit confused exactly what she meant by kinesthesia, but I think it just means like, I know like kinesthetics means motion, dealing with motion, so I'm thinking maybe it has something to do relating with motion. So, but I'm not 100% sure what this is, but I know like kinesthetics means like motion, right? Does anyone have an idea? Okay. Okay, so did I lose anyone so far? Okay. So you guys already knew this, or did you guys already know this?
More or less.
More or less? Okay, cool.
Is there any difference between the two proprioceptions? The one from the spinocerebellar and the one from the dorsal column?
I guess you can kind of see that one of it is unconscious because it goes to the cerebellum, right? Whereas the one for your the dorsal column is actually conscious, right? You're more like you're actually just going to the higher areas of your brain.
So if you like close your eyes, isn't that I forgot what it was. When that came up with the thing when I don't do this Robinson test. Like isn't that a form of reading the proprioception? Proprioception? One of the things that Dr. Wilson was talking about is means by which to evaluate. I believe it was a cranial nerve lesion when it was when you think about visual or auditory issues, like you have but one of them is you have it's an auditory issue, you're closing your eyes when you stand and things
You lean over and
With the
fall.
vestibular?
yeah, with the vestibular. So is that something where you'd be losing proprioception relative to the spinocerebellar tract? Or not necessarily. But that would seem like it also might deal with kinesthesia.
I see your point. I mean well, I see your point. Well, honestly, dude, I cannot remember. It probably does have something to do with it. But I'm not 100% sure. Not 100% sure. Anyone have any anyone want to chime in? No? Not at all? Okay. Okay, so okay, so all right, so let's say here, right? So this is our spinal cord, right? So which one is the gray matter? And which one is the white matter? Okay. And then which one will be the white matter? The one outside, right? Okay, so then we know we have the what? The dorsal horn, right? Then we have the ventral horn, right? And then we said for the ventral horn, that's where you're going to have like the motor neurons, right? And then for the dorsal horn, we're going to have the sensory neurons. Okay, so out here, somewhere out here, we're going to have the dorsal root ganglion, right? We're going to have the dorsal root ganglion. And something else is also important. We're going to see this a little bit later on. I should probably... Okay, so around here, so maybe around here we'll have like the nucleus gelatinosa, and then below that we're going to have the nucleus proprius. All right, so these are going to be a little bit important. They're going to be important later on, the nucleus gelatinosa and the nucleus proprius. Okay, so now when we have this, the sensory information, right? So the first neuron is going to be located here in the dorsal root ganglion, right? So here. So the first neurons, they're going to be located here at the dorsal root ganglion. So you can imagine that so like here, this probably be like the receptor, right? and then this would be the cell body, right? And then it will send like its axon, right, into this gray area here, like gray matter here. So depending on which like track we're dealing with, or which pathway we're dealing with, right? So we might synapse here, or we might not synapse, we might just like go directly up, right? So depending on which track we're talking about, it can differ. Okay, so for example, if we're talking about the dorsal columns, so what would happen is that, so the cell body would be in the dorsal root ganglion, and then the axon wouldn't actually make any synapses. It would actually just travel up like so, right? So it would literally just travel up like so, right? For the spinothalamic, so again, you would have like the receptor, and then your cell body would be in the dorsal root ganglion, but then you would synapse either at the nucleus proprius, so you would synapse here, right, at the nucleus proprius or the nucleus gelatinosa, and then the secondary neuron is actually going to decussate, right? So it's actually going to cross, and then it's going to like travel up like so, right? And then for your spinocerebellar, it's a little bit different. But I'm just showing you guys that it can be different. But the major thing is that for all of these things that we're going to consider, for all these tracks that we're going to consider, so for all of them, the primary neuron, or that primary cell body, is going to be here. Yeah.
In regards to this Spinothalamic Tract, one of the things that's kind of come up is that the whole notion of, you can kind of see that it's crossing.
Yeah.
The notion of this pain or symptoms contralateral to the side of the lesion.
Yeah.
One thing that was that notion, Dr. Wilson was trying to get at is like a lesion, I guess, at T1, you end up, I guess, you were there, I think, it ends up manifesting T3, T4. I remember he was discussing the notion of, I forgot whether he was saying whether the lesion is at T1 or the lesion is at T4, and that it's coming contralateral, but it'll also be like one or two segments up and to the right. In histolab. I guess the point that he was getting at is what he was there. He was saying like you'll have a lesion that like on a board question or on a test question, let's say it's on T1 there, you're actually getting your issues two segments down, contralateral. And I just wanted to know relative to like the cell body we have drawn there.
Yeah.
That just because the track will be going down in two more segments.
Yeah, isn't it because like when it comes in, it doesn't necessarily have to synapse at that segment.
Yeah.
Two segments, and then synapse there.
So it can. Yeah. So it's called the track of Lissauer. So what I got from the lecture is that it generally climbs up before synapsing, right? So before synapsing onto this guy here, so it can like climb up. Well, that's what it generally does. It generally climbs up, right, before synapsing. And let me see if I can give you guys some.
So it will have already gone, most likely have gone up 2 levels when it gets to that primary cell. What? Okay. That would be.
Wasn't it limited to the secondary?
That's what I'm saying. What we do there for primary.
nucleus, that's the cell bodies of the secondary neuron.
Okay, so yeah, that's what I'm saying. So what you do there when you talk about primary cell body, is what we're talking about. That would be you technically have a secondary cell body there. Or where is the secondary cell body?
Secondary cell bodies are into the stem.
All right, so here, this is what you're talking about, right?
Yeah, that's the thing. Technically, hasn't already ascended.
Yeah, that's small ascending, small,
Oh,
and
okay,
it's big ascending itself.
Oh, okay, okay, okay.
Right? What did you say?
It goes up, it goes like a small 8 centimeter thing, goes up a little bit, then desiccates, then goes to tract, then goes up. What is that?
All right, so here we're looking at the Spinothalamic Tract, right? So what we're saying is that that primary neuron, so the cell body is going to be in the dorsal ganglion, right?
Mm-hmm.
So what I had shown was I was showing it synapsing like that,
Okay.
and then moving and then going up like that. But so this can happen, but generally, what generally happens is that it can move up, like it moves up, and then synapses at the the nucleus proprius or the gelatinosa. Then once the synapse is there, then like it would decussate and then move up. Right? You see it?
Okay, so in that case, the secondary cell body would be at either place where you're showing that.
Yeah. So it's just the secondary cell body will be here, like here, it'll be here, something like. Well, they have multiple synapses in here. It's a little bit weird, but it will be here somewhere. That's how it's shown. Cool. And this tract right here is known as the tract of Lissauer, right? So the tract of Lissauer. All right, so I guess maybe just going in a little bit more detail. So starting off with the dorsal column. So when we're looking at the primary neuron, so we just said that it's going to be in the dorsal root ganglion, right? Right? That's what we just said. So it's going to be the dorsal root ganglion. So we have the receptors for this. So you guys remind me what is the dorsal column? What is it like helping us to detect? Okay, so touch, proprioception, and pressure. Okay. Okay, so specifically, so the kind of receptors would be like your Merkel, Ruffini, and your Meissners. All right, and these guys are for touch, right? Then you have your Pacinian corpuscle, which is for vibration. And then you have your muscle spindle and your Golgi tendon. And that's going to be for proprioception. All right, so here we have the proprioception, right, coming from the muscle spindle and the Golgi tendon. We have the vibration coming from the Pacinian corpuscle, the Merkel, Ruffini, Meissner for touch. So these receptors, right, are going to be sending information, right, to this primary neuron, right, which is located in the dorsal root ganglion, right? And then this neuron is going to synapse. All right. it's going to synapse in your nucleus, either in the nucleus gracilis or your nucleus cuneatus. And we'll get into this in a little bit. All right, so but the primary neuron is located at the dorsal root ganglion. Secondary neuron is going to be located either in your nucleus gracilis or your nucleus cuneatus. All right, and these guys are located in your medulla oblongata. All right, then the tertiary one is located in your thalamus. Right. So specifically the VPL, ventral posterior lateral nucleus of your thalamus. All right, so from here to here, we're going to get a decussation, right, which just means that it crosses over, right, to the other side, right? All right, and then the last neuron is going to be located in your primary somatosensory cortex. Somatosensory cortex. So primary somatosensory cortex. All right, so we have the primary neuron, the primary cell body. The primary neuron is going to be located in your dorsal root ganglion. The secondary one is going to be located either in your nucleus gracilis or your nucleus cuneatus. Right? So it depends on where the sensory information is actually coming from. So the gracilis one is actually it's going to be like it gathers information from like the lower part of your body, so like from your legs downward. Whereas for the nucleus cuneatus, it's going to be gathering information from like your hip upward, excluding your face, right? Then you're going to have then from here, right? It's going to send off axons. It's going to cross over, send off axons, and then it's going to synapse in your thalamus, which is your tertiary, right? Tertiary neuron is there. And then from the thalamus, it's going to send off the axon, it's going to synapse onto your primary somatosensory cortex. Okay, so when we're talking about the nucleus gracilis, right? So this is sensory information. It's going to be coming from like your legs. For the nucleus cuneatus, this is sensory information. It's going to be coming from like your upper body, right? Now specifically for this, I believe it's T6 to S5, and then for this one is T5, C1 to T5. So this is kind of like it's like this is where the information will be coming from, like from this level. And then for your cuneatus, it'll be coming from this level. All right, let me see if I can get a better picture for this sound. This might be the best way of explaining this. All right, so this is the dorsal columns and the medial lemniscus pathway. So essentially what we said is that we're going to have the primary cell body is going to be in the dorsal root ganglion, right? So from that dorsal root ganglion, the secondary cell body is going to be either in your nucleus gracilis, right, or your nucleus cuneatus, right? And the tertiary cell body we said is going to be in the thalamus, right? Specifically the VPL, right? Now you do have the VPM being involved, but that's like for the facial aspect. All right, so when you're looking at T6 to S5, so we said that's going to be for the gracilis, right? So this is like gathering the sensory information from your lower body, like the lower part of your body, and then it's going to travel like up and then synapse in your nucleus, like gracilis. Whereas like from C1 to T5, it's going to be gathering information from like your upper body, right? And then that information is going to ascend up and it's going to synapse onto your nucleus cuneatus, right? And then both of them are going to travel, right, up to your thalamus, right, and synapse in your thalamus. All right, so did you guys get to this? I think this is pretty straightforward. All right, so that's basically that for the dorsal columns. So just remember that the dorsal columns, so the major thing is that it's dealing with touch, proprioception, right, and pressure. So the primary cell body is in dorsal root ganglion. Secondary cell body is either in the nucleus gracilis or the nucleus cuneatus, right? So depending on what aspect of the body, so if it's the lower part of the body, it's going to be synapsing onto the nucleus gracilis. If it's like upper body, it's nucleus cuneatus, but both of them are going to decussate and then synapse onto your thalamus. And then from the thalamus, they're going to synapse onto your primary somatosensory cortex. Cool. So I got this cough. It's not helping me. All right, so now moving on to the spinothalamic. All right, so for the spinothalamic, so we said this is basically pain and temperature, right? All right, so we're going to see the same exact thing. So the primary neuron, the cell body is going to be in the dorsal root ganglion, right? So in terms of like the receptor, okay, so it's pain, temperature, and crude touch, right? So in terms of the receptors, so you're going to have your noise receptors. You're going to have your thermal receptors. Really, both of these guys are free nerve endings. Right? So this primary neuron is going to synapse, right? Either in your nucleus proprius, probably not spelling that right, the nucleus proprius, or your substantia gelatin, Glyanosa. Right, so this is where it's going to be synapsing onto. So from here, it's going to send off, from this place here, it's going to send off axon, right? And it's going to move to your thalamus. So it's going to synapse onto your thalamus, and it's synapsing in the VPL of the thalamus. Then from here, right, from the thalamus, the neuron there is going to send off an axon, and it's going to synapse onto your somatosensory cortex. Right? Okay, so what we said is that from the dorsal root ganglion to like getting like the synapse here, so we can have, so instead of this axon synapsing on the same level as this nucleus proprius or this substantia gelatinosa, it could actually travel up. So it could actually travel up like 1 or 2 levels. And once it travels up 1 or 2 levels, then it can synapse onto that like neuron in the nucleus proprius or the substantia gelatinosa, right? So once it synapses onto the neuron in the nucleus proprius or the substantia gelatinosa, then it's going to cross over. So at this point here, we're going to get a decussation, right? Right. Once we get the decussation, then it's going to travel. It's kind of hard to depict this. Let me go back to the. All right, okay, so, all right, so, it's a depiction of your spinothalamic tract, right? So right here, we're seeing the cell bodies in the dorsal root ganglion, right? I think everyone can see this, right? So cell bodies in dorsal root ganglion. Now, the neurons here, these primary neurons are going to send off their axons, and it's going to synapse either in the nucleus proprius or the substantia gelatinosa. Now, generally what does happen is that the axon will travel up and synapse. But it could synapse on the same level, but generally what happens is it sends off the axons and then it synapses like up here somewhere. Right, but it can't synapse on the same level. Once it synapses onto the secondary neuron, then the secondary neuron is going to send off its axons, right? So it's send off the axons, so it's going to cross over, right? So it's going to decussate at this position here, and then it's going to move up like so. So it's going to be following this tract. So there's like a spinal thalamic tract, like located on the side here. It's going to be following that. Then it's going to be traveling up, and then it's going to make its way to the VPL of the thalamus. And then from the thalamus, then it's going to project to the somatosensory cortex. Right? You guys see that? Okay, so another thing is that, so in addition to having like these ones that I'm talking about, so you also have the facial one, right? So the difference with the facial one is that, well, when you look at the thalamus, it's going to be synapsing onto the VPM, so like ventral posterior medial, as opposed to the ventral, like the lateral, the ventral posterior lateral, right? So, and notice that this primary neuron is not located in your dorsal root ganglion, right? So that primary neuron is going to be located, let's see, where is this? Where did I put this? Okay, so let's trigeminal ganglion. So this is going to be located in trigeminal ganglion, right? And then the secondary neuron, so the secondary neuron here is going to be located in the spinal, this is spinal nucleus of cranial nerve 5. Right? So the primary neuron is going to be located in your trigeminal ganglion, and the secondary one is located in the spinal nucleus of cranial nerve 5. Right? So it's differences, and then the tertiary neuron will be in the VPM as opposed to the VPL, right? All right, so I guess maybe we'll just kind of briefly talk about the spinocerebellar tract. Okay, cool. All right, so, oh shoot. Okay, so when you're looking at the dorsal column, right, and the spinothalamic tract, so you have to look at the complete person, right? So you have to look at like from head to toe. So we've just been considering just the body, right? And so the body fits into this little schematic here. So when you're looking at a dorsal column and you're looking just at the body, the primary neuron is located in the dorsal ganglion. The secondary neuron is located in the nucleus gracilis, nucleus cuneatus. Tertiary, yeah. So when you start talking about the head, it gets a little bit different. All right. So in terms of the head, so for the dorsal column, in terms of the head, let's see what I got here for the head. It's a little bit slightly different. Okay, yeah. All right, so the primary neuron is still going to be in the trigeminal ganglion. Yeah. Wait, no, wait. Okay, so trigeminal ganglion for the spinothalamic and for the dorsal column. You understand what I'm saying? So, all right, okay. Let's backtrack. Dorsal root ganglion. Dorsal root ganglion is for the body. Trigeminal ganglion is for the head, right? That's cranial nerve 5, right? That's for the head. So, let me pull this other thing. The major thing is this, right? When you're looking at these two tracks, you have to figure out, you have to like isolate the body and then the head. So the pathway for the body and the pathway for the head is different. You understand what I'm saying? And so, like, I guess you just like take note of that. So if you're just talking about the body for the dorsal column, the primary neuron is in the dorsal root ganglion. The secondary neuron can either be in the nucleus gracilis or the nucleus cuneatus, depending on which part of the body you're coming from. So if you're coming from like the segment from T6 to S5, you're synapsing in the nucleus gracilis. If you're coming from C1 to T5, you're synapsing in the nucleus cuneatus, right? But then both of them are going to move up. They're going to decussate and then move to the thalamus and then synapse in the thalamus. And then from the thalamus, they're going to send off axons and then they're going to synapse in the primary somatosensory cortex.
Does it decussate at all?
Yeah, it's decussates right here.
No, the face.
Hmm?
The face.
For the face? Yes, the face decussates as well, yeah. Did you see that? So let me see if I can pull up what the slide.
So when you keep saying face, are you saying like the dorsal column for the face, or?
Here, don't worry, let me pull up the slide. I think it'll make more sense from the slide. Yeah, this is a little bit, this needs a lot of visuals. Okay. Okay, so let's start off with the dorsal column. Okay, so this is the dorsal column, right? So where do we say the primary? Okay, so if we're talking about, this is the body, and this is the face, right? So when you're looking at the body, that schematic I showed you applies, but there's a slight difference when you're looking at the face in terms of how it projects. You see what I'm saying?
Right.
There's
So it's still like the dorsal column before the face. Or does it have?
Hmm?
It's still like.
It's still a dorsal column. It's still a dorsal column, but it's for the face. You can see it that way. Yeah. So when you're looking at the body, the primary neuron is located in dorsal root ganglion, whereas for the face is the trigeminal ganglion. Right. And so then for the secondary neuron, so when you're looking at the body, so it's either going to be the nucleus gracilis or the nucleus cuneatus. Right? But when you're looking at the face, so it's going to be your chief, it's going to be chief sensory nucleus of cranial nerve 5. All right, so that's what that's going to be. All right, and then from here, it will then decussate and then go up to your VPM and the synapse into the VPM and then move on to the somatosensory cortex. So it's just a slight difference when you consider the face. So the schematic I just showed was for the body, but then there is a slight variation when you're looking at the face. Cool? All right, you guys look confused and lost. Yeah, okay, so, huh? Okay, I think the mistake I made with this requires a lot of visuals. And I feel like the way I'm approaching this is not.
Wait,
It requires a lot of visuals.
What's her name
Yeah.
posted? I forgot. Somebody posted something on Facebook. It's a really good video. Yeah.
The one up on it has all the names.
Oh, okay. Okay,
So,
yeah.
when you were talking about the spinal nucleus of cranial basically, what was that? Or is that the same thing as the sensory nucleus?
No, it's two different.
Yeah, so you the spinal, so the spinal sensory nucleus.
Spinal nucleus of cranial.
Yeah, so that was for the other one. That was for the spinothalamic. All right, so did you get it? Does that make sense? So it's just a matter of just separating the body from the face. So it's still the same, still the same track, but the way they get up to the brain is a bit different when you're considering like the body and then the face.
Was the tertiary one for the dorsal column in VPM or VPL?
VPN.
VPM.
Wait, you said for the body? Oh, for the body VPN.
Yeah.
And with Dr. Shaw said and then with BPM, sort of mask, BPM, mask, and then BPL made. You know,
All right, so maybe we could just go through the spinocerebellar tract, right? So when we're looking at the spinocerebellar tract, so we said that it's going to be divided into two different tracts. So you're going to have the dorsal spinocerebellar tract, and you're going to have the ventral spinocerebellar tract. So what did I say, dorsal and posterior. One second, let me go back. This is actually a little bit confusing. Okay, so when we're looking at the spinocerebellar tract, right? So we're saying that we're gonna have there's two other tracks or two other pathways involved in it. So you have the dorsal pathway and you have the ventral pathway. So the ventral pathway is also like anterior, like ventral anterior. So the dorsal pathway is then further divided into your cuneo-cerebellar tract and your dorsal spinal cerebellar tract. Right? All right, so this is just kind of showing you guys the cuneo-cerebellar tract. So remember for the dorsal pathway, so you're gonna have the cuneo-cerebellar tract, and you're gonna also have like the dorsal spinocerebellar tract. So both of them are within dorsal. It's a little bit confusing, right? So when you're looking at the cuneo-cerebellar tract, so okay, so the dorsal, the primary neuron is in your dorsal root ganglion, just like what we've already kind of established, right? So the primary neuron is in your dorsal root ganglion. Now notice that the receptors, so here you have like the muscle spindle and your Golgi tendon, right? So these guys are coming up, right? The afferents is the primary neuron. Now the axon is gonna go through here, then it's going to move up and it's going to synapse into your accessory cuneate nucleus. And then from here, it's going to travel through your inferior cerebellar peduncle, and then it's going to synapse in your cerebellum. Right? Notice that there's no decussation, right? So when you're looking at this cerebellar tract, there's no decussation, right? Right. Now, so when you're looking at the dorsal spinocerebellar tract, and I'm just trying to see if I can get through this really fast because we're spending a lot of time on this. Okay, so when you're looking at the dorsal spinocerebellar tract, so again, the primary neuron, right, it's going to be located in your dorsal root ganglion. Notice that it's the muscle spindle and the Golgi tendon that are the receptors, right? So the axons are going to move, and it's going to synapse here at your nucleus dorsalis of Clark. And then from here, it's going to move up like so. And again, this is the inferior cerebellar peduncle. And then from here, it's going to synapse onto your cerebellum.
So it just goes through it doesn't synapse there, right?
On the cerebellum? Or where?
After inferior cerebellar peduncle.
Yeah, it just goes through it. It just goes through it. So the synapse is here at the nucleus dorsalis of Clark. All right, so this is more of like the confusing one. So the ventral spinocerebellar tract is more of the confusing one because it actually, at the end of the day, it's still going to be the stuff is still going to be on the same side, but it's actually going to like decussate 2 times, right? So if you look at the dorsal spinocerebellar tract, and you look at the cuneo-cerebellar tract, remember both of these were under the dorsal, right? Both of them were under dorsal, right? The dorsal pathway, right? Dorsal pathway, and this was ventral pathway. So when you look at both of these guys, like they don't actually decussate, so there's no like decussation. So there's no decussation for this, and there's no decussation for this, right? But when you look at the ventral, so again, here we have the Golgi tendon as the receptor, right? The primary neuron is the dorsal root ganglion. Then we're going to have the synapse here at the dorsal horn, right? And then the axon is going to move across, and then it's going to travel up like so. So this is the first decussation here, right? First decussation occurs here, and then it's going to move back, so the second decussation will occur here, and then the synapse is onto your cerebellum. Cool? But at the end of the day, so you're still going to be like on the same side. It's still on the same side essentially, even though it decussates like a couple of times. So this right here. Did you guys see that? Okay, so it synapses at the dorsal horn right here. And then it moves across, and then it goes up, like so.
They just didn't give it the nucleus.
All right, so those are the tracks for Dr. Gondry. Those, yeah.
Is it desiccate after the superior cerebral peduncle? After it leaves there?
Yeah. So, yeah, you can see it. Like,
basically.
Once it crosses like this little midline structure, like if you draw a line here. So decussation just means it goes on the other side. Yeah. All right, so that's basically the ascending pathway. Right, so it's just you have your dorsal column, you have the spinothalamic tract, and then you have your spinocerebellar tract. Just remember that the spinocerebellar tract is unconscious. Remember that the dorsal column, spinothalamic tract is conscious. So you're actually aware of the information. Just be aware for these guys. Be aware that like you have differences like when you're considering the information traveling from the body or with the information traveling from the head like up to your brain. So there's differences in the pathway, right? Which I just kind of like showed you guys. So you guys just want to like take a note of that. Does anyone have any questions for this? All right, so let's see how much I could get with these guys. I don't want to keep you guys here too long. Okay, so let me just quickly just go to the orbit. I'm just gonna briefly I'll talk about it briefly, not like I won't like talk like about it a lot, just briefly.
Can you do the H test?
H test? Is it H test? What's that?
Look down with right,
but
left,
it's like
and
it's
test
supposed
for
to
the
cancel out
adducens
something.
versus directuses to see what's your speech.
I have no idea what the H test is. I mean, I can go through like the muscles and the.
It's just the.
Would you guys rather? Huh?
Just look left,
Did you
look
go
up,
Yeah,
look
you
down,
just
look right.
Do you know?
Yeah, I get it.
Yeah, I get what you do.
I remember it, but I can't like.
I get how it isolates that you like, okay, now looking for the inferior oblique and now looking at the superior oblique versus the rectus.
No, it was like if you
Yeah, that's
AD done, your superior oblique will only be able to compress or like stuff like that.
Yeah.
You get it?
Yeah.
Why?
Basically, if you're abducted for vertical movements, you're using your recti. If you're abducted, and then if the eye is adducted for vertical movements, you're using the obliques. So like it would be to look up would be the inferior oblique, and to look down would be the superior oblique. So basically,
That's what the angle of the eye is, right?
Mhm.
No, I know for the adductions because when you're at a right angle, you can't use the oblique to look up. That's the rectus that is the sole mover at that point. Versus when you're in the other direction, you're at an angle that compromises the rectus, so it's the oblique that's moving.
so if your left eye looking to the left, you're using the recti to look up or down. But the right eye would be using the obliques, and then vice versa. If you're looking to the right.
So basically, if you're abducted and then you look up, then you'll be using your inferior oblique.
If you're abducted,
Yeah.
no, you'll be using your superior rectus.
Superior rectus.
Mhm.
Okay.
But if you're abducted
And you look up, then that's your inferior oblique.
Exactly.
Well, it said some of them would like intort and extort. So
Okay, so do you guys want me to go over the muscles and the
we know
what,
that.
you guys already know the muscles and stuff?
Yeah.
Okay, yeah, I mean I remember It's just like when you follow, like when you're making an H, right?
Mm-hmm.
Isn't that what it is? H test, right?
Yeah.
I kind of forgot it, but yeah. So like, what? So what about it? What about?
That's
So
right in lab, that they do on the board, that's wrong. So we took a copy of that paper and what they wrote on the board on the back of lab today. Some people will go look at it, but that was wrong. We have like the right side obliques and stuff.
So like, isn't it just? I think it's just like when you so you're just testing like the muscles of the eye, but you're essentially drawing. I think you're just drawing an H with your hand,
Yeah.
and then you're trying to get the person to follow. You know, like you drawing the H with your hand. You know
Yeah,
what I
I
mean?
know that. She doesn't understand like why if you look in a certain direction, it's just testing this specific muscle and not
And it
other
would cancel
muscles.
out some of its functions if you work one way. It will only do one of its three functions.
Oh, okay. I see. I see. I see your point.
Look at the chart where it has the partial, like, intorsion versus extorsion along the rectus muscles that they did. Because that'll help you piece it together.
You talking about, are you talking about
There's
this?
just like a picture where it also has like the arrows and the other arrows coming off perpendicularly.
I think that's Dr. Gillen's, like, first lecture about preparing the head of the smile.
Because look, this is why I assume that if you A these up, then and you look up, then you can just create a rectus. And when you A these up and look up, then
Would you to the number 4? Yeah, like that. Is it not
oh, I don't use it. That doesn't make sense. I don't use that.
Can you go look at what they do on the pathway?
But the electrons basically.
Did you guys already dissect the eye in the lab?
Yeah.
Are you talking about?
Because this is what you're talking about.
It was this one, so he was saying,
You remove the frontal bone.
No, we expose like
Yeah, this is
the
basically the
ocular
same
motor
thing.
nerve.
Yeah. Because it's like, because I know, is there another chart that shows all the functions? Sometimes it does have three functions each. Like this chart shows that they have three functions.
But if you move your
So
eye
I'm trying to
to the
think.
aerial, it's indicating.
So are you guys good with the orbit?
Anything else.
So if you
Because I can slightly talk about maybe certain things, about it. But if you guys are already good, then we can go to the thalamus. If that's what you guys. So you guys are good with the orbit?
Yeah,
Yes.
we'll just,
Straightforward.
we'll figure out the H test.
Okay,
Yeah.
cool.
They'll figure it out.
Well, you saying why it was increasing?
But it's people mind the function of the
Did you apply for the SSRP?
what is that?
Just the research on camping.
Hmm?
I did not understand his lecture, except for like 2 things.
Okay.
Honestly, I just did it because when he talked to me about it, and I was just like, okay.
And he said the better.
No, it's just, I was like, okay, this, that. Got it.
So you just memorized it?
Okay.
Okay.
That's on roll.
So maybe just some general ideas. So the thalamus is like
I was listening.
the thalamus is kind of like the size of like a cashew, right? So typically it looks something like this. If you want to draw both of them, like it looks something like this. So like so. So this would be like a thalamus. So maybe like it's roughly the size of a cashew. Now, so the thalamus is going to be serving as it serves as a relay station. Right. So it's going to be relaying primarily sensory information. Right. So let's just say here. Let's say this right here is a cortex. And then right below the cortex, we have the thalamus. Right. So basically, the thalamus is going to be receiving information from the cortex. Right? And as well, it's going to be sending information to the cortex. Right? So the information that's going to be, like the information that's going back and forth, right? So this information could be sensory, right? Some of it is motor, and some of it is autonomic. So, but primarily the thalamus is going to be serving as kind of a relay station, information like we just saw like from the Spinothalamic Tract, right? The dorsal column, we saw that all that information was going up to the thalamus, right? Before it reached the cortex. So like sensory information is going to move to the thalamus, and then once it gets to the thalamus, then it goes to the cortex. So the thalamus is kind of like relaying information to the cortex, and as well, the thalamus is going to be receiving information from the cortex, right? So what Dr. Burke talks about is, he talks about how there's this kind of 40-to-1 ratio, right? 40-to-1 ratio meaning, so the 40 is in representation of the cortico-thalamic projections, right? So there's more information going from the cortex to the thalamus than there are information going from the thalamus to the cortex, right? So this would be thalamocortical. All right, so there's this kind of like 40-to-1 ratio. So there's more information coming from the cortex to the thalamus than you have information going from the thalamus to your cortex. All right, so you guys kind of, I don't know if you guys are kind of getting where I'm going with this. So we're saying that the thalamus is, it's about the size of a cashew nut. So it's going to be primarily serving as a relay station. It's going to be interacting with the cortex. It's going to be relaying sensory information, primary sensory information, but also you're going to have motor information that's going to be going through there. Autonomic information would also be going through there. Now, the only sensory information that does not pass through the thalamus is olfactory. So the olfactory will not pass through your thalamus, right? So your thalamus is part of your diencephalon. Right. So there are other structures that are associated with the diencephalon that was mentioned in the lecture. So you have the epithalamus, right? Well, you have the thalamus, which we've already mentioned, right? You have your hypothalamus, and then you have your, the subthalamic nucleus. See if I can just quickly sketch this thing out for you guys. All right, so, all right, looking at this here, so roughly the thalamus would be here. So around here, so you have the thalamus. Okay, so what would this be? I know you guys probably know this. All right, so your corpus callosum. All right, so right around here you have your pineal gland. All right, and somewhere around here, you have something called the I think it's the habenular nucleus. If I'm not wrong, he had something like this in the lecture. Habenular nucleus. So both of these guys, the habenular nucleus and the pineal gland, they make up your epithalamus. All right, and then right around here, you're gonna have your hypothalamus. And you guys know what this would be? Okay, so the pituitary. But this looks so much different on the screen. It looks so much different on the screen. Okay, so this would be the pituitary gland. And of course, this is the pons, right? Medulla, and then this is the midbrain. All right, so the pineal gland is going to secrete melatonin, right? And it's involved in the sleep-wake cycle, right? So, I mean, I just remember him saying that last year, so I thought it was important to just point that out to you guys. The subthalamic nucleus. Now, I didn't depict the subthalamic nucleus. I didn't depict the subthalamic nucleus here. It will be kind of hard to depict, but the subthalamic nucleus is part of your basal ganglia. Your hypothalamus, right, is going to be serving to regulate, right, the endocrine system, right. And we just talked about the thalamus. It's like a relay station, right? The epithalamus, part of the epithalamus is the pineal gland, which is going to be secreting the melatonin, which is involved with the sleep-wake cycle. Okay. So now, when we're looking at this thalamus, we're seeing it as this kind of a relay station, and we're seeing that like sensory information is moving into the thalamus and then it's going up to the higher centers of the brain. So because you have like all of these sensory informations coming up to the thalamus, so kind of scientists were kind of thinking along the lines that because you have all this sensory information in one place, that the thalamus can kind of serve as a center of consciousness, right? Because if you have all of these kind of sensory information in one place, so they're kind of seeing the thalamus not just like in the restricted sense of just being a relay station, but that it has a higher function of like playing a role in our consciousness of like our surroundings, like our conscious awareness of our surroundings. So that's particularly important. Okay, so this interaction between the cortex, so this interaction here between the cortex and the thalamus is important, right? So you guys should just take note. There's going to be interaction between the cortex and the thalamus. All right, so
the cortical thalamic projection, is it only the ones from the cortex to thalamic, or is it both ways?
So you said cortical thalamic. and then thalamocortical. All right, so let's just say this is the thalamus, right? And let's say this is the cortex. So we're going to have information being sent, right, from the thalamus to the cortex and from the cortex to the thalamus. Now, the majority of the information will be traveling in this direction, right? The majority of the projections will be in this direction, right? Because we said it was 40-1, right? So there's more projections from the cortex to the thalamus than there are from the thalamus to the cortex, right? Now, it turns out that the neurons, so the neurons of the thalamus and the neurons of the cortex, so these guys are glutaminergic. All right, so by glutaminergic, we mean that these guys are excitatory. All right, so the thalamic neurons, the neurons in the cortex, so they're going to be glutaminergic, so they're excitatory. So it turns out that the information does not, it doesn't just go from one neuron here and then just synapse like so, like so. So it turns out that there's actually an in-between. There's like a, you might call it maybe like a mediator, all right? All right, so you have these reticular neurons, right? And these reticular neurons are going to they're going to be modulating the information that's going between these two guys. These reticular neurons, they will specifically, they're going to be sending information, they're going to be like sending projections back to the thalamus, and they're going to be inhibiting the thalamus. So these neurons here are going to be GABA, well, they secrete GABA, so they're going to be inhibitory. Right? This is the best way to. Okay, so maybe the way to kind of get you guys to kind of see this. Okay, so let's just suppose that, okay, let's suppose that there's a neuron here, right? Right? So let's say we have a neuron here in the cortex, right? And this neuron here is trying to synapse with a neuron in the thalamus, right? So let's just say it sends off an axon. And let's say that this axon reaches this neuron, but at the same time it reaches this reticular neuron, right? So let's say it reaches this reticular neuron. So let's just say that this glutaminergic neuron fires. If it fires, then it can like activate this neuron in the thalamus, right? But at the same time, it would be stimulating this reticular neuron, right? So, but this reticular neuron could have an inhibitory effect on this neuron here. And so because it can have an inhibitory effect on the neuron in the thalamus, then it would kind of be modulating that excitatory signal. Do you guys see that?
Yeah.
So that's kind of like, I guess that's the way I kind of understood it. So the reticular neurons are kind of modulating the signals being transferred. You know, so you have some control over it. So it's just not like, it's not always like excitatory.
Are they facing both ways?
What do you mean by?
Are they like inhibiting the other way too? Like do they?
It's just the thalamus. It only inhibits the thalamic nuclei.
Okay.
You guys see this? Yes. No. Okay, so now another thing. So when you're looking at this thalamus, right? So there's going to be two different kinds of modes by which the thalamus is going to be relaying information to the cortex. All right. So there's two different modes that it's going to use to relay information to the cortex. So you can have the burst firing, or you can have the tonic firing. All right. So notice, okay, so all we're talking about is how this information is being relayed from the thalamus to the cortex. So we're just talking about this. We're not talking about the information coming from the cortex back to the thalamus. We're just talking about the thalamus to the cortex. So the thalamus, there's two different modes by which that thalamus can now relay information to the cortex, right? So we're saying that in the thalamus, the neurons there are glutaminergic, right? The neurons in the thalamus are glutaminergic. That means that they are excitatory, right? These excitatory glutaminergic neurons, they have two modes by which they relay information to the cortex, right? The first is through what's known as like the burst firing, and then the other one is the tonic firing. Make sure this is yeah. Okay. Now, okay, now this should conceptually should make sense, because what is more noticeable, burst or tonic? If your tonic is like it's almost like it's like flatline kind of a thing, right? But if it's a burst, it's more like it stands out, right? Okay. So the burst firing is usually the signal that is used to wake you up from sleep. And it's usually the signal that gets your attention. Say you're watching a movie or something like that. It's usually the signal that would be sent to get your attention. So it's kind of like you're in the zone and you're just kind of like this, and it's the burst firing that will actually get your attention, as opposed to the tonic. The tonic would be you watching the movie and just being like baseline. You know what I'm saying? So this is the signal that wakes you up from sleep. This is the signal that it's used to get your attention. Right? And the tonic firing is more of like the consistent, right, signal. Right? Now, another way that you can kind of use, or that was used in the lecture to further give an idea of the burst firing and the tonic firing, so is this concept of signal to noise ratio. Right? So there's this concept of signal to noise ratio. Okay, so for the burst firing, the signal to noise ratio is going to be high, whereas for the tonic firing, it's going to be low. Okay, now let me explain this further. Now let's just say that the noise, let's say right now, all you guys are talking, and then I'm trying to talk. It's going to be hard for someone to hear me. Why? Because there's a lot of background noise. So what I'm trying to say is not going to come out clearly. So what I'm trying to say is a signal. and you guys talking is the background noise. And the ability for someone that's actually trying to listen to me to actually hear what I'm trying to say is going to be compromised if there's a lot of noise. So all they will be hearing is just, it'll be tonic. So if this ratio is low, then we're supposing that the noise is high, right? So if the noise is high, then you can't really hear the signal, and so all you're really hearing is just noise. And because all you're hearing is just noise, then all you're getting is tonic firing. It's just the same thing, right? Whereas for the burst firing, the signal to noise ratio is high, meaning that the signal is actually pretty high, and the noise is not all that high, so you could actually hear me very well. So if you're actually listening, you would actually be hearing me, and so you actually, like, what you're hearing is a clear signal. So I guess the best way to think about it, so that's the signal that gets your attention, if that makes sense, because the tonic wouldn't get your attention. It's still the same thing. Yeah. So.
Yeah, so is it the result of the noise being low, or is it the result of a signal being high? Because I know where he says something about hyperpolarization. Lecture. Kind of put for a hand down or something like that.
Yeah. For bursts to happen, first has to hyperpolarize below its normal depolarization state, and then it goes up higher. That way the amplitude is larger. See if the hyperpolarizes, and then it goes up. That way the amplitude is larger. Then that's your burst mode.
Yeah. So I mean, does anyone? Did you already answer his question? Or?
So you said hyperpolarization needs to happen?
Yeah.
That has to happen first.
Okay.
Before burst mode. Hyperpolarization makes the amplitude larger, and then the burst mode occurs.
Okay.
So you may see increases the detectability.
Doesn't it usually like a low threshold stimulus?
Oh yeah, sure. That's a question. So you don't explain to me what this just basically before you move on simple, but can you explain to me the purpose of this burst tonic thing? Is this for cortical dynamic or cortical or cortical dynamic? Cortical, like what signal is this for?
Yeah. So from what I got from the lecture, is the way the thalamus is interacting with the cortex.
So this is the cortical.
Yeah.
And this is the GABAergic. And the thing, you said boost chemical.
Yeah.
Never mind.
Yeah, the GABAergic was for the reticular neurons. So those ones were inhibitory. All right, so this is just a little bit of an idea of the thalamus, right? So the major thing, just know that it's a relay station, right, between the cortex. So you're going to have information moving back between the cortex and the thalamus. The thalamus is going to be taking sensory information from the body, relaying it to the cortex. Know that there's more projections going from the cortex to the thalamus than from the thalamus to the cortex. And then just kind of know this kind of little schematic here of how the reticular neurons are kind of modulating this kind of interaction. So the thalamus and the cortex are talking to each other, but then there's like a mediator in between there, meaning like the reticular neuron is like a mediator, serving as a mediator. You just kind of know that the thalamus, cortex, glutamatergic neurons, know that the thalamus has two different modes of firing, right? And just kind of like what those modes of firing could, maybe like what it could actually result in, or what it could cause. And then the other last thing I was to quickly just kind of talk about is just the different nuclei, the different thalamic nuclei, and just briefly.
mentioned the function of the subthalamic nucleus area?
I said it was part of the basal ganglia. All right, so just really fast here. So this is just again the depiction of the thalamus here. Again, we're just quickly just pointing out some of these nuclei, maybe some of the raw structures that you see when you look at the thalamus. So first here, this interconnection between the two, the thalamus. So you have this intrathalamic adhesion here. Right. So roughly you're gonna have like cell masses. So you're gonna have like a medial cell mass. You'll have a medial cell mass. You would have like an anterior cell mass, and you would have a lateral cell mass. Right. So the lateral cell mass is like further like divided even more. And then in the center here, so right here, you're going to have an internal medullary lamina. Right? So it's just kind of like dividing them up. So the lateral cell mass is going to be further divided up. So it's going to be further divided up into your lateral posterior, your lateral dorsal, ventral posterior lateral, ventral posterior medial, ventral I think it's intermediate or intermediate, something like I think it's ventral intermediate. Then you have ventral lateral, and then you have your ventral anterior. Maybe a way to kind of get you guys to remember this. So the ones up here, these are lateral, right? Like they're beginning with, like they begin with L, right? And then the one below that, these guys are beginning with V's, right? So these are all V's, right? And this makes sense because it's anterior and this is medial, right? And you just got to remember that the lateral ones are on top. The ones that begin with lateral are on top. And then the ones that begin with ventral are further on the bottom. Then you just kind of makes sense because it's anterior, ventral, anterior, right? Ventral posterior, this makes sense as well, right? Lateral posterior makes sense as well. So I think from there it kind of makes sense. We kind of like reason it out and figure out what's where. So right here you have your pulvinar, right? And then here you have your lateral geniculate nucleus, right? And then here you have your medial geniculate nucleus. The lateral geniculate nucleus is responsible for like vision, like relaying like visual information. The medial geniculate nucleus is going to be responsible for auditory. So relaying auditory information.
Is that an A next to the lateral?
Where are you saying here? Right.
Next to the lateral posterior. Is that lateral posterior?
What are you talking about here?
The yellow thing that's the one.
Here?
So
I'm not.
that's the-
Right here?
Yeah.
So you said, is that a what?
What is that?
This here? LP, lateral dorsal. This is LP and this is LD. All right, so as roughly speaking here, okay, so these guys right here are going to be relaying motor information. Right. Whereas these guys right here, so the VPL and the VPN, your lateral genicular nucleus, your medial genicular nucleus. So these guys right here are going to be relaying, this is going to be sensory information. It almost seems like it's the same color. All right, then for the lateral dorsal, right? Then the anterior nucleus. So these guys right here are going to be relaying autonomic / limbic, it's related information. Right, then you're going to have the more of the non-specific nuclei. So in terms of the non-specific ones, so you have the intralaminar nucleus or nuclei. You have the pulvinar, and you have your medial dorsal. Okay, so here we talked about the medial cell mass. So remember, roughly we said we'll have the medial cell mass, right? We have the anterior cell mass, and then we have the lateral cell mass. Now, this medial cell mass does have further divisions. So one of such divisions is the medial dorsal, right? So in terms of non-specific nuclei, so it's not like a specific kind of information that is relaying, right? So you have your intralaminar nuclei. So the intralaminar nuclei are actually within this internal medullary lamina. So it's like somewhere in there. That's where I'll be located. Then you have the pulvinar, right? The pulvinar is this right here, right? That's a pulvinar, right? And then the medial dorsal will just be the dorsal part of this medial cell mass. Cool? Yeah, so this is just, and again, this is just an overview. I mean, I know I wouldn't have enough time now.
Did you leave out lateral posterior pelvis?
Hmm?
Lateral posterior.
I probably did. I mean, there's a lot of stuff with this. There's a lot of information.
Can you shrink it a little bit?
there's a lot of information on this. So. Cool. All right. You guys seem tired and weak. But I understand. Okay, so how about we just how about we just ask questions?
You want to do the first, I don't know.
It's all good. I don't want to keep you guys here too
I
long.
was gonna start the first one. Okay. Oh my God. Wait, line is first. Is that I meant to open.
Okay, so I guess the first question I'll ask you guys. So we have more information traveling. So more information is traveling from where to where? Is it from the thalamus to the cortex, or from the cortex to the thalamus? Okay, cortex to thalamus. So let me see here. So the neurons, the neuron in the reticular neuron, the neurons, or the reticular neurons rather. So what kind of neurotransmitter do they use? The reticular neurons. Okay, GABAergic. So that information will be synapsing where? Okay, onto the thalamic nuclei. Did he talk about I don't know I mean, I'm not sure if my notes were right, but because what I had in my notes, I don't think we had this recording, the recording of his lecture, but I had in my notes that the reticular neurons, like they're not part of the thalamus. Hmm? That's what I had. I had in my notes that it's not part of it. I was wondering if he said that in you guys' lecture. Did he ever talk about if the reticular neurons were part of the thalamus?
That's what reticular nucleus is, isn't it?
In his notes, he said it's not.
It's not, right? Yeah, that's what I had in mind. But then I was a little bit, because when you look in the slide, like there's, okay, let me show you what I'm talking about. It's a little bit I just don't know if I took the wrong notes, or so I just want to be sure. Let me pull up.
Well, here it says, these are notes from last year, and it says reticular nucleus is part of the thalamus.
Okay, so if you look here, right? So this right here is reticular nucleus. So it's like, it says it's pulled away. Pulled away. So I was a little bit when in my notes I had him saying that it was not part of the thalamus. But then when you look at these depictions, like, let's see. Okay, like if you look right here, you can clearly see this is the reticular nucleus. You know what I mean? And it seems like it's part of the thalamus. So maybe you guys can, maybe ask Dr. Burke to see like what he actually wants, because it's a little bit Okay. Yeah, just be a little bit clear. I mean, I have it in my notes that he said that it's not connected to it. It's not part of the thalamus. But I'm not 100% sure about that. All right. So the next question. So what are the two modes of firing for the thalamic nuclei? Your bursting and tonic. So which one is more of a consistent signal? Okay. And which one is what does the other one do? The burst firing. What is that doing first? Okay, so it wakes you up, gets your attention. So which one has the higher signal to noise ratio? Okay. And then the tonic firing would have what, a lower, right? Okay. All right, so we mentioned some structures that were part of the diencephalon. So what were some of the structures that we mentioned that were part of the diencephalon? Okay. Okay, so we have the subthalamic nuclei. Okay, so we have the epithalamus, thalamus, and this is strictly from his notes. I mean, from his slides. What else? Does anyone remember anything else? Okay, so we got the hypothalamus. Okay. Anything else? Okay. So then we said the epithalamus had like two components, or two major components. Now I might have the spelling wrong. I don't think it's wrong, but it might be wrong. But I don't think it's wrong. Yeah, habenular nucleus. And then what was the other one? Yeah, the pineal gland. So what did the pineal gland secrete? Okay. And what was the function of the melatonin? Okay, sleep-wake cycle. So yeah, I'll just ask maybe just a couple more questions on the other stuff that we talked about, and then we'll just call it a day.